All right, plan for this recording is to talk through the Chapter 3 review worksheet. So let's get rolling. Question number 1, find the equation of a line tangent to a curve. In order to find the equation of a line, I need the slope and I need a point. I've given you a part of a point. I've given you the x-coordinate. I have not given you the y-coordinate. So let's go ahead and find the y-coordinate. So f of 9, go to my function f, plug in 9. 2 times 9 is 18, minus 2 is 16. The square root of 16 is 4. So I know the x and the y-coordinate. X is not 2. X is 9. And y is 4. So there's my xy coordinate. Next thing I need is the slope. The slope of a curve is the derivative. And so I want to find the derivative of this thing. I'm thinking of this as 2x minus 2 raised to the 1/2 power. So I'm going to use both a power rule and a chain rule because my inside function is more than just x. So the outside function 1/2 comes down in front. Leave the 2x minus 2 alone. Decrease the exponent by 1. Multiply by the derivative of the inside function, and I get that derivative. Plug in 9, because that is the x-coordinate I'm looking at, and so I get the same basic expression as what I have above, raised to the negative 1/2 power this time, times 2. So this becomes 16, just like above. Square root of 16 is 4, but that makes it 1/4. And so I have 1/2 times 1/4 times 2. Square root of 16 because of the 1/2. 1 over that because of the negative exponent gives me 1 over 4. 2 times 1/2 is 1, times 1/4 is 1/4. Y minus y1 equals m times x minus x1, and I'm done. Number 2. Instantaneous rate of change simply says find the derivative. So we have a bunch of stuff going on. We have power rule, we have chain rule, we have implicit differentiation, all 3 concepts. Derivative of the outside function 3 comes in front. Derivative of the inside function, so I'm multiplying times the derivative of the inside function. This is a product rule. Sorry, go back to here. This is a product rule. First term is x, second term is y. So derivative of the first times the second plus the first times the derivative of the second. I'm going to use y prime instead of dy dx. Okay, so that's the derivative of xy raised to the 3rd power. Chain rule, derivative of the outside function, 3 comes in front, decrease that by 1 gives me that expression. Multiply by the derivative of the inside function gives me this expression. Okay, continuing on down, the derivative of 4x squared with respect to x is 8x, and the derivative of 8 is 0. I would plug in 2 right now for x, and I need y. So let's go back over here. When x is 2, this becomes 2y to the 3rd power plus 4 times 2 squared equals 8. This becomes 8y cubed plus 2 squared is 4 times 4 is 16. Subtract, and I get 8y cubed equals a negative 8. Sorry. And I divide, and I cube root, and y is a negative 1. So I go back over here. I plug in 2 for x. I plug in negative 1 in for y. We are multiplying that. Plug a negative 1 in for y. Plug a 2 in for x. looking for y prime, plug a 2 in for x. Let's simplify that mess. Negative 2 squared is 4 times 3 is 12. Subtracting 16 gives me that. I could distribute and all that stuff. I'm just going to divide by 12 right now. 16 divided by 12 is a negative 4/3 when we reduce that. I'm going to add 1 to that, and I get 2y prime equals. Adding 1 means I'm adding 3/3, and I get a negative 1/3. Dividing by 2, multiplying by a half, and I get 1/6. Timesing both sides by a half. Okay. What is the instantaneous rate of change? We're done. Doesn't ask for an equation, just asks for the derivative. Okay, question 3. Find the second derivative. Well, my first step would be to find the first derivative. So derivative of 4y squared is 8y. That's my outside function. There's a y now on the inside. So I multiply that by y prime. And that's the derivative of this here. 2 times 4 is 8. Decrease the 2 to a 1. And I get 8y. Timesing by the derivative of the inside function, which is y prime, which is y, which gives me y prime. Or dy dx. Derivative of 2 is 0. The derivative of 3x squared is 6x. Solve for y prime. And I get 6x over 8y. I'm going to reduce it just a little bit, and I get y prime equals 3x over 4y. You could have taken the derivative again right here and done product rule. That would have been totally fine. Okay, I'm going to use quotient rule now using y prime. So y double prime equals the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. The derivative of 3x is just 3. And then we have 4y. The derivative of 4y is 4y prime because it's a constant times a function. So the derivative is the constant times the derivative of the function. And the derivative of y is just dy dx or y prime. Okay, in terms of x and y, I have this y prime here. I'm going to take what y prime equals and substitute it in for y prime. So y double prime equals, combining the 3 and the 4 gives me 12y. Combining the 3 and the 4 gives me 12x times y prime, which we know is 3x over 4y, all divided by 16y squared. If you got it to here, it's technically right, but they're not going to give you that option in a multiple choice. They're going to reduce that down or simplify that by taking and multiplying top and bottom by the denominator of the fraction that's inside of the fraction. So I have this 3x over 4y. I'm going to multiply top and bottom by the 4y so that this fraction goes away. This is being distributed to the entire top. 12 times 4 is 48. Y times y is y squared. 4y goes away. 3 times 12 is 36. X times x is x squared. On bottom, 16 times 4 is 64. I have y squared times y gives me y cubed. Phew. Question 3 was a doozy. All right, question 4. Just going to take a bunch of derivatives. Don't need to simplify, just checking rules. Do we understand all the different rules? So, f prime. I see a couple things. I have power rule and I have chain rule, because what's inside the power, where there is normally an x, is not just x. So I have chain rule. Bring the 4 in front. Leave the 5x minus 3 alone. Decrease the exponent by 1. Multiply that by the derivative of the inside function. The derivative of 5x is just 5. The derivative of 3 goes away, and there is my f prime. You do not need to multiply and get 20 and so on. Just, you're done. Okay, b. Y prime equals. I can see a bunch of stuff going on. I'm going to slide further over. Y prime equals. Remember, I can write this as 3 tangent of 5x raised to the third power. This expression and this expression are the same thing. The 3 is not being raised to the third power, just the tangent 5x. Okay, bring the exponent down in front, multiply it by the coefficient, I get 9. Tangent, 3 becomes a 2, 5x gets left alone. I've done the exponent. I've taken care of the most outside function. This is x raised to the third power. The next most inside function, notice I'm not looking at this. I'm going back to my original function. The next most inside function is tangent. The derivative of tangent is secant squared, leaving the 5x alone. Okay, I've taken care of the exponent. I've taken care of the tangent. Now I have this 5x inside. Derivative of 5x is just 5. Notice how I'm always going back to the original function to move inside. From the 3 down to the tangent into the 5x. If you try to go to here, not only is it wrong, it's going to make it super confusing. Go back to the original function. Okay. See, I'm thinking of this as raised to the 1/2 power. This is a square root, so I'm raising it to the 1/2 power. So y prime, I got chain rule. 1/2 comes in front. Leave the inside mess. Decrease this square root, decrease that 1/2 by 1, giving me a negative 1/2. I've taken the derivative of the square root part, the outside function. Multiply by the derivative of the inside. The derivative of the inside is just 8x minus derivative of sine is cosine. And we're done. Not too bad. Don't need to simplify, so we're done. Okay, I see a mess. I see an implicit differentiation going on because I have x's and y's all in the same expression. So we're going to do implicit. Leave the 3 alone. We do need a bracket because we're going to have a mess inside of here. You could use a parentheses there too. That's fine. They're both grouping symbols. It doesn't matter. The derivative of cosecant is negative cosecant. Cotangent. Notice my inside xy does not go anywhere. The derivative of cosecant is a negative cosecant of the expression times cotangent of the expression. Multiply that by the derivative of xy, and we have a product rule going on. Derivative of x, there's my first term, there's my second term. The derivative of the first times the second plus the first times the derivative of the second equals the derivative of 7y squared is 14y times the derivative of the inside function, which is y, which gives me a y prime. Now you may ask, why isn't the derivative of 4y y prime? Why is it just 4y prime? How come I don't have another y in here? And the reason is the derivative of this is just the derivative of a constant times y. Just like the derivative of this isn't 3x, it's just 3. Whereas here we have an exponent, and so I get 14y. I haven't taken the derivative of y yet. I've just taken the derivative of the exponent. Now I take the derivative of the inside function, which gives me the y prime. Okay. Letter E. We got a lot going on letter E. All right, let's be careful as we talk through this. I see two functions being multiplied together. I see this second function as a mess, but still I just have this function being multiplied times this function. To be probably more accurate, I probably should have thrown a time symbol in there. Okay, talking through product rule. Derivative of the first. The derivative of an exponential is the original function, 2, 3x minus 1, multiplied by the natural log of the base. If that base is an e, you're not going to have this because it's just 1. But if it's anything other than e, you will have the natural log of the base being multiplied by that original function. Okay, my exponent is not just x, so now I have to multiply that by the derivative of the exponent. So the derivative of 2 raised to a power is 2 raised to the power times the natural log of 2 times the derivative of the exponent, which is a 3, because my exponent is something other than just plain x. Okay, derivative of the first, done, times the second. Notice how I started over talking myself through chain or a product rule, because there was so much. Sorry, I can't talk and write at the same time. Let me write this first. Because there was so much going on, I needed to make sure I went back and talked myself through the product rule. Derivative of the first is this big, huge mess. Times the second, just rewrite it. Plus the first times the derivative of the second. So derivative of natural log. My natural log is the outside function. The derivative of natural log is 1 over the expression. What expression? That mess. Derivative of the outside function times the derivative of the inside function. Derivative of sine is cosine. So I've taken the derivative of sine. Now move inside to my last inside function, which is 8x. Now technically all of this can slide on top, but it says at the beginning, don't simplify. I'm done. Talking myself back through. Derivative of the first times the second plus the first times the derivative of the second. The derivative of the second, natural log is the most outside, so it's 1 over the expression. Then it's the derivative of sine. Then it's the derivative of 4x squared. You should be able to go back through and see each part of the derivative. Okay. I'm going to erase this, so if you need to see it again, you'll just need to rewind the recording, because I need my space. All right, y prime equals, the derivative of arctangent is 1 over 1 plus x squared. But where there's normally an x, there's not an x. There is this 3x plus 1 squared, and that is being squared because it's 1 over 1 plus x squared, and my x is that big, huge expression. Okay, since that is my x, I now have chain rule. So the derivative of this now, most outside function is 2. Leave the 3x plus 1 alone. 2 goes in front, decrease the exponent by 1. Times that by the derivative of the inside function, which is a 3. And again, this can come up on top, do a little rearranging, but I don't need to. Sorry, I get these random marks where my pencil touches down. All right, G. All right, here we go. F prime equals product rule, chain rule going on. So the derivative of a logarithm is 1 over the expression, but we have this negative sign here. I'm just going to stick that negative 1 out there. 1 over the expression. Okay, so if it's natural log, it's 1 over 3x. Now it's 1 over 3x still, times 1 over the natural log of the base. If you want to change this into natural log and then take the derivative, totally fine. If you change that into natural log, it'd be the ln of 3x divided by the ln of 4. And now take the derivative of that, thinking that it's a constant times the function ln of 3x. So this would be 1 over ln 4, which is where that comes from, and the derivative of this is just 1 over 3x. Okay. Once again, I'm going to start over and talk myself through product rule. Derivative of the first, done, times the second, plus the first. My first term is a negative log, so I'm just going to change that, plus the first, times the derivative of the second. Remembering the derivative of a arc sine is 1 minus, sorry, I got interrupted there for a second, which is 1 over 1 minus x squared square root. And we're done. Okay, letter H. Again, if you need to see this, just rewind your recording. All right, letter H. Y prime equals, I see quotient rule, so let's dive in. Derivative of the top, e to the 3x plus, I'm going to run out of room, I can see that already. Y prime equals derivative of the top, e to the 3x plus 5 times the derivative of the exponent. So there's the derivative of the top times the bottom. Just rewrite. I'm missing a letter. I'm assuming that is a cosine x squared. Or cosine squared. I don't know. That's what it is now. It could be a COT or a COS. Yeah, I don't know. I'll make it a cosine. The derivative of the top times the bottom minus the top times the derivative of the bottom. Derivative of cosine is a negative sign. No, sorry. Whoa. My outside function is a 2, so I'm going to do 2 down in front. Leave the cosine alone. Now multiply by the derivative of cosine, which is a negative sign. And finally by the derivative of the inside. And technically I need parentheses around here, but I know if I throw them in there, it's going to make a mess. So there's parentheses around that 2x. Well, I can't not. All right. All over the bottom squared makes it cosine to the 4th of 2x. And it's just looking over at your review, and those are not on there. So I'm not sure how they got taken off. Anyways, yeah, yours stops back there at F, and it's actually an E on, I don't know. I'm not sure what happened. Somehow it got cut off. Oh well. If you wanted to go back and do those before I did them, you're welcome to. All right, question 5. Find the slope of the line tangent to the curve at the point. Back to implicit differentiation. So I have derivative of x to the 3rd is 3x squared. The derivative of 2y cubed is 6y squared times dy dx, which is y prime. And again, we've seen xy lots. Derivative of the first times the second plus the first times the derivative of the second. You should have that almost memorized. The derivative of xy is y plus xy prime. Okay, plug in 1 and 1. That becomes 3 minus 6y prime plus, plugging in 1 gives me 1 plus y prime. Don't need the parentheses anymore. Combine like terms, I have the 3 plus the 1 gives me a 4. Moving it to the other side gives me a negative 4. Combining a negative 6 and a positive 1 gives me a negative 5y prime. And again, I don't need the parentheses because there's technically a 1 sitting right there. Divide, and I get y prime equals a negative 4 divided by negative 5, which we should make a positive 4 over 5. And we're done. Y prime equals 4 over 5, which represents the slope of my line tangent to the curve. Number 6, find the equation of the line. Back to question number 1. At the point 1, 1, this time I give you both x and y, whereas in the first one I gave you just x. We should be getting better at these techniques, so I'm just going to cruise through a little bit faster maybe. I have product rule, two things being multiplied together. I have implicit differentiation because I have x's and y's all going on at the same time. So derivative of 3y squared is 6y times y prime. 3 times 2 is 6, leave the y alone, multiply by the derivative of the inside function, which is y prime. Okay, again, going back and talking through product rule, derivative of the first times the second plus the first times the derivative of the second plus the derivative of 6x, which is 6. The derivative of 9 is 0. Plug in 1 for x, plug in 1 for y gives me 6y prime, because that's a 1 and that's a 1, plus 3 plus 6 equals 0. 6y prime then must equal a negative 9. Adding that together, moving it to the other side, and dividing by 6, and I get y prime equals a negative 9 over 6, which I can reduce to a negative 3 over 2. I am not done. That is my slope equation. Y minus y1 equals m times x minus x1. All of this was to find the slope at the point 1, 1. All right. Question 7. Use the graphs below to find the derivative of h prime, or derivative of h at negative 2. So first question, what is the derivative of h? I see chain rule, derivative of my outside function, leaving the inside alone, multiplied by the derivative of the inside function. Plug in 2, so h prime negative 2 gives me g prime of f of negative 2 times f prime of a negative 2. F of negative 2, go to my f graph, negative 2, f looks like 6, so now it's g prime of 6. F prime of negative 2 looks like my slope is down 1 over 2, so it looks like this is a negative 1/2. G prime of 6. Here's 6. G prime looks like a negative 1, down 1 over 1. So a negative 1 times a negative 1/2 would be 1/2. Double check G. G of 6, G prime of 6. My slope here is a negative 1, and so I get 1/2. Oh, negatives. No, it's not negative 6. Sorry, I was looking at my answer key. My answer key says something different. So I need to just hit pause and make sure I know which one's right. Yeah, sorry, my answer key is not right. This is right. At least my double checking. F of negative 2 looks like it's 6, so that becomes a 6. G prime of 6, we're jumping over here now. G prime of 6 looks like it's a negative 1 times negative half. I like this one, not the answer key. Sorry. All right. Whoa, what's happening? Trying to move that down so I can write. There we go. All right. Find m prime of 1. So derivative. We got quotient rule. Derivative of the top. F prime times the bottom minus the top times the derivative of the bottom all over the bottom squared. Plugging in 1 gives me f prime of 1. I'll go and do it all out. G of 1 minus f of 1 times g prime of 1. I probably didn't have to do this step. All over g of 1 squared. All right, f prime of 1. F prime of 1 looks like 0, so that first term is going to go away. F of 1 looks like 5. G prime of 1 looks like a positive 1. The slope of that curve. G of 1 looks like a negative 2. So negative 2 squared becomes a 4. 0 minus 5 is a negative 5. All over 4 gives me negative 5 over 4. All right, that is done. Calculator part, page 2. Whole bunch of word problems, related rate problems. If you struggled with the related rates, this will be a great half hour. Well, maybe a great half hour. It'll be a learning, hopefully, half hour. All right, I like pictures. We have a 13-foot ladder leaning against a wall. So here's my little picture. That wall extends up further. This is a 13-foot ladder leaning against the wall. The base of the ladder is being pulled away from the wall at a rate of, oh, my deal didn't fit on here. Let me grab that and shrink it. Oh, I didn't cut it all off. Oh, maybe I did. Maybe we're good. Okay. Base of the ladder is being pulled away from the wall at the rate of 2 feet per second. So I'm going to call this, nope. I'm going to call this x. I'm going to call this y. And so I know that dx dt, the rate at which the x is changing, the base of the ladder is being pulled away from the wall. So this x value is getting bigger. So this is going to be a positive 2 feet per second. And I'm just going to write 2 because that's my dx dt. At what rate is the top of the ladder moving down the wall? So what is dy dt? How fast is this distance changing? When the ladder is 5 feet from the base. Okay, so we wrote down all of our information we want, or all the information we know, and let's write a relationship between the two quantities, x and y. So x squared plus y equals 13 squared. Take the derivative, so 2x times dx dt plus 2y times dy dt equals the derivative of 13 squared, which is a constant, so it is 0. So remember my thought process so that you can get better at these. I like to write down all the information I know in calculus notation. Then I need a relationship between the variables I want and the quantities I know. or the variables that I know, if that makes sense. So I have these three pieces of information. What's the relationship between those three pieces of information? I'm assuming a right angle, so I know Pythagorean theorem. Okay. Then, sometimes at this point in time, I would substitute in what y equals or what x equals in terms of the other variable. However, I can't do that, or I don't want to do that, because I need both of these. I need the rate at which it's sliding down the wall, and I know and need the rate at which it's moving away from the wall. I need both of these variables in there. I can't replace one. In some of the volume problems that we did earlier, the reason we replaced it is because we had like volume equals 1/3 pi r squared h. I have three variables, and it's kind of nice to only have two, especially when you only know information about two of the three. Okay. Plug in what I know. dx dt is 2, x is 5. So this is, can we do it all in our head? No, I won't, sorry. 2 times 5 times 2. Plugging in 2 for dx dt, plugging in 5 for x. Okay, I don't know why. So go back to my relationship. X squared plus y squared equals 13 squared. X is 2, 2 squared is 4, plus y squared equals 13 squared, which is 169. Subtract, and I get 165. Square root, and I get y squared equals this, or y equals the square root of 165. So this becomes 2 square roots of 165 dy dt equals 0. I'm solving for dy dt, so I'm going to multiply this together. 2 times 5 is 10, times 2 is 20. Subtract the 20, and I get 2 square roots of 165. Oh, sorry, I plugged in the wrong thing. Sorry. Hopefully you caught that. This isn't 2. This is 5. I plugged in the rate, not the x. 2 is not what I want. I want the 5. So this becomes 5, right, when x is 5, not when I don't want that. I want that. Sorry. Hopefully you caught that and you were wondering what in the world I was doing. Let's resolve with the right number plugged in, and I like that much better. Square root of 144 is 12. I know this is not good English, but it just makes so much more sense. It's so much more better. More better seems more better than just better. Sorry. It's been a long day. All right, so 2 times 5 is 10, times 2 is 20. Plug in a 12 right here, and I get 24 dy dt. Subtract. Divide. And I get a negative 20 over 24. 5 goes into both of those, and I get a negative 4 goes into both of those, and I get a negative 5 over 6. All right, number 8, all done. Number 9. Okay, here's my suggestion. As soon as you get to the point where you think, I might be able to do one of these, try one on your own, and then come back, hit pause, and then come back and listen to the explanation. So if number 8 kind of makes sense now, then hit pause and do number 9. Or, while I'm doing number 9, if you still are struggling, if there is some point in time when I give you a kind of a hint and you're ready to go, hit pause. Whenever you can hit pause and do it on your own, I highly encourage you to do that. Okay, the volume of a large spherical balloon. Spherical balloon. Pretend I can draw 3D. This is a sphere. So dV dt. The volume of a large spherical balloon is increasing at the rate of 64 pi meters. It is increasing, so it is positive. At what rate is the balloon's radius changing when the radius of the balloon equals 2 meters. So in this time, I just wrote down the calculus information as I was reading it. You don't have to do that. Sometimes it's really nice just to read the whole entire question, then come back and put in your information. Okay, for this one I really didn't need a picture. Volume of a sphere is 4/3 pi r cubed. I just have one variable over here that v is equal to, so I don't need to replace anything or do any solving. Just take the derivative. I want dr dt. I know dv dt, so I need to take the derivative of both sides with respect to t. So the derivative of v with respect to t is just dv dt. This is a constant. 4/3 pi is just a constant. So I take the derivative of r cubed, multiply it by 4/3 pi. Okay, so the derivative of r cubed, I bring the 3 in front, multiply it by the coefficient. 4/3 times 3 is just 4. Decrease the exponent by 1. Times by the derivative of r with respect to time. Plug in all the stuff I know. And solve for what I don't know. In this case, there's no r's to solve for, there's no v's to solve for. I just need dr dt. So up here I had to do a secondary step. I had to find out what y equals by doing all my work, but I don't have to. Just solve. I know everything except for dr dt. So this becomes 4 times 4, which is 16 pi. Divide both sides, writing and talking at the same time. Divide both sides by 16 pi so that this goes away, and I get dr dt by itself, and I get dr dt equals 4. For what? 4 meters per second, because the balloon is in, the dimensions of the balloon is in meters, and so it's, and per hour. It's 4, man, I can't write and talk tonight. So this is 4 meters per hour. All right, number 10. That one wasn't too bad. That would be considered a semi-easy, if there is such a thing as an easy related rate. If that helped, if that made sense, hit pause, try question 10. Question 10, Jacob is flying his drone at a constant speed of 20 miles per hour away from him. So here is Jacob. He's flying his drone at 20 miles per hour away from him at a constant height of 300 feet. So his drone, I won't even try to draw a drone, is sitting up here going this direction, 300 feet. So this distance is 300. And I'm going to call this x. So dx dt, it's going away from him, so the distance is increasing as time is increasing at 200 miles per hour. Okay, at what rate is the angle of elevation? So Jacob is looking up at his drone. Angle of elevation is not this angle, it is this angle. If we did another triangle going this direction, this would be x, this would be 300, this is my angle of elevation. How far from a horizontal does he need to raise his eyes and look up in order to see his drone? That's the angle of elevation. This is not the angle of elevation. It's this right here. Okay. So, relationship between theta, 300, and x. I know that tangent of theta, we do need to change this a little bit, but we'll talk about that here in a second maybe. This is 200 miles per hour. This is 300 feet. We'll have to do some changes, or we can just cheat and change that to feet per second, because I won't do that to you on the test, but we'll keep going. Relationship, tangent, is equal to opposite over adjacent. So there's my relationship. You can leave it like this. You can multiply it and do a product rule, but I'm going to think of it as, whoops. I'm going to think of it as a power rule, just because it seems to make it nice and neat. The derivative of tangent is secant squared. The derivative of this mess, bring the 1 in front, makes it a negative 300. Decrease the exponent by 1, makes it a negative 2, times the derivative of the inside function, which I forgot to do over here. Times the derivative of the inside function. And we have our derivative. Theta in this picture is 300 over x. Sorry. The secant is going to be, remember secant is 1 over cosine, so it's hypotenuse over adjacent. So I need my hypotenuse. The hypotenuse in this case, let's get some numbers in here. This is 900. So my hypotenuse is the square root of 300 squared plus 900 squared. Right? And so the hypotenuse is a big mess. Grab my calculator. So grab my calculator, I get a big, huge number. 900,000 for this here. So square root of, didn't like my pause, square root of 900,000 over, right? So it's, that over needs to be all the way outside. Square root of 900,000 divided by 900, right? So it's, this over here is the square root of 900,000, and secant is hypotenuse over adjacent. Normally it's cosine, which is adjacent over hypotenuse, but it's secant, so it's hypotenuse over adjacent. And then we are squaring that. So this becomes 900,000 divided by 900 squared. d theta dt. And at any point in time, you can go to a decimal. But when you go to a decimal, you have to go to 8 significant digits, or just leave the numbers on your calculator and don't round it until the very, very end. Negative 300. Remember what this means? It means over, right? What was x? When it's 900 away, 900 squared. And dx dt is 20 miles per hour. And so here's where I'd have to change that 20 miles per hour into feet per second. I'm not going to make you do this, but 20 miles per hour, feet per second, there's 5,280 feet in a mile. So we have 5,280 feet is 1 mile. So these go away. And then we have 3,600 seconds in 1 hour. 1 hour. So these go away. And so if I multiply that whole big mess together, I'm going to hit pause and do it real quick. When I multiply that together, I get 29.333333, so 29 1/3 feet per second. Why did I need to do that? Because these are all in feet. Get rid of this thing. These are all in feet. This is in miles per hour, so I have to convert that. So it's going to be 29 1/3. If you're looking at my answer key, it's wrong because I forgot to change that. All right, do some number crunching, multiply all that together, divide it by that mess. d theta dt equals, I'm just going to get a decimal here, I'm going to get a decimal here, and I'm going to divide them. Take this number and divide it by this number. Again, I'm going to hit pause, and then you do the same thing and type. when I work that whole big mess out, I get negative, doesn't like pause, I get negative 0.0097. So technically, if I'm doing a calc test, AP Calc at the end of the year, this would be 0.01. Rounding to the nearest, no, 0.10. Rounding to the nearest hundredth makes that go to a 10, which makes it 0.010 negative radians per second. Now, what is that saying? That's saying my angle is getting smaller as the drone moves away, which it would. As the drone moves away, this angle, right, if I go a little bit further away and a little bit further away, this angle is getting smaller, which makes sense. Notice it is different than my negative 0.00667 that's on the answer key because of this 29 1/3. Okay. Your turn. All right, spotlight on the ground, 20 feet from a wall. I like pictures, so I'm going to go a little higher up. Taking up too much space. So here's my spotlight sitting on the ground, 20 feet away from a wall. That is a fixed distance. That spotlight's not moving. A 6-foot tall person, dude sitting right here, or gal, we don't know if it's a dude, 6 foot tall, is between the wall and the spotlight, walking towards the wall at a rate of 2.5 feet per second. How fast is the height of the shadow changing when the person is 8 feet from the wall? So we have some things to figure out. What do you want to label what? Okay, so person is walking towards the wall. We have a shadow, right? How fast is the height of the shadow? So the spotlight's casting a shadow. The shadow is going to be laying out here or sitting up here up on the wall somewhere. So here's my spotlight. Here's my shadow. I'm going to call the shadow Y. Do we all agree that that's the shadow? Person, spotlight, shadow, right here. Okay. Where's X? Is X going to be this distance, or is X going to be this distance? From the spotlight to the person, or from the person to the wall? What do you want to call X? Here's what I would call X. I would call this X. And here's why. I'm looking for figures, ways of relating X and Y together. And what I notice is I have a triangle right here made by the person, X, and the ground. And I have a triangle right here made by the distance from the ground to the spotlight and the shadow. So I have a way of relating these two quantities. Okay? So this dx dt then, the person is walking towards the wall, and so that dx dt is increasing at 2.5 feet per second, so it's going to be positive. This is a constant of 6, and what I'm looking for is what is the height of the shadow when the person is 8 feet from the wall, which means when X is equal to 12, because the person is 8 feet from the wall makes this distance 12. Okay, I want to know what is the rate at which the height of the shadow is changing. So looking at similar triangles, I have this triangle here, I have this triangle here. That is my relationship between X and Y. So I know that the ratio of the height of the person to the base of the triangle is equal to the height, said it right, wrote it wrong, height of the person compared to the base of the little triangle is equal to the height of the shadow versus the base of the big triangle. we could find the derivative right now. We could do a whole bunch of stuff. I'm going to solve this thing for y, just because I think it would make it easier. I'm going to multiply both sides by 20. So I end up with 120 over x equals y. And now I'm going to find the derivative because that's what I want. I'm going to think of this like I did before as 120. I have a suspicion I'm not recording, so I'm going to hit just make sure I'm recording. Okay, sorry. I've hit pause so many times with the calculator. I want to make sure. Okay, so I have 120 x to the negative 1 equals y. We okay with that becoming that? And now I have a simple exponent. Negative 120, decrease the exponent by 1, multiply it by dx dt equals the derivative of y. And we got that. Plug in what we know. We know x is 12, so this becomes 144. So this becomes negative 120 over 144, because that's x squared. Negative puts it on the bottom. Dx dt we said was 2.5. Multiplying that mess together, and I get negative 2.083 when I multiply it, feet per second. Would it make sense that as the person walks towards the wall, the shadow is decreasing? As the person walks towards the wall, is the shadow really going to decrease? Yes. As the person walks over here, now the person sitting right here, still 6 feet, the shadow is no longer the same height. When the person is right here, the shadow is no longer the same height. When the person hits the wall, the height will be 6 feet. Okay. That was a side note. All right, your turn. Question 12. Road running north-south crosses a road going east-west. That's pretty easy to draw. Let's see if I can draw a straight line. Not too bad. At point P. Car A is driving north, so car A is going north. Along the first road, car B is going east-west. So let's just call that A, and let's call that B. At a particular time, car A is 10 kilometers north. So I'm going to call this X. I'm going to call this Y. So at some point in time, X is equal to 10. And is traveling, dx dt, at 80 kilometers per hour. Car's driving north, so that 80 is positive. Okay, while car B is 15 kilometers to the east of point P, so that's 15, and is traveling at 100 kilometers per hour. So let's keep looking. Car B is driving east, so car B is driving east, north, west, east, south, right? So driving east, so it is also a positive 100. How fast is the distance between car A and car B changing at this instant? So we know the relationship is x squared plus y squared equals the distance squared. So we know that the square root of x squared plus y squared equals d. And I want to know how fast is that distance changing. I want dd dt. Seems kind of a weird way of writing it, but that's what I want. I want d dt, the rate of change of the distance in terms of the rate of change of time. Thinking of this as a 1/2, I have 1/2, oh sorry, backtrack. Do I have any constants that I can plug in right now? Nope. That distance changing because the car is driving. That distance changing because the car is driving. None of these are constants, so I have to leave all 3 variables in there. But luckily, I know all the information I need. I know information about all three variables. Well, I know information about two of the three. So I think we're going to be okay. Let's start doing it. This is a 1/2 exponent, so leave the inside alone. Decrease the exponent by 1, and now multiply by the derivative of the inside function. Erase this because it's not far enough over. So derivative of the x squared is 2x times dx dt plus 2y times dy dt equals d dt. Double check. Bring the exponent down in front. So this is a 1/2 exponent sitting out here. Bring it down in front. Decrease the 1/2 by 1. Leave the inside mess alone. Times the derivative of the inside function, which is 2x dx dt plus 2y dy dt. That's an x. Okay, plug in what I know. 1/2 x was 10. 10 squared is 100. Plus y, which is 15. 15 squared is 225. This is a calculator part, so you can do all of this on the calculator if you're stressed that you can't do what I just did in my head. Okay, times 2 times x, which is 20, dx dt, which is 80, plus 2 times y, which is 30, times dy dt, which is 100. Grab a calculator, type that mess into your calculator, get a final value for dd dt. Working that all out, you should get what I have on my answer key, 127, 3 decimal places. Get in the habit of 3 decimal places. Kilometers per hour. Whoa, what was that? Kilometers. Wow, my calibration must be off. I think I'm hitting one link and I'm hitting something different. All right, kilometers per hour. Why is it a fraction? Because of this thing, not a fraction, but a decimal because of that thing right there. Okay. All right, now we're getting a little easier. Particle moves along the x-axis so that at any point in time its position can be given by that expression. AP Calc folks love particles moving on the x-axis. All we're saying is, here's my x-axis, could be a number line, same idea, and this particle is moving back and forth along this, and its position is given by this, where at some point in time t, you can plug it in and find out where it's at. This is positive, this is negative, this is my 0. And if you could throw a y-axis on here if you want, but we don't need it. We just need the number line. Okay, calculate the velocity. So the v of t is equal to the derivative of x of t. So I have 4t to the third power minus 6t to the second power minus 12t plus 9. 9. Not too bad. Compute the particle's velocity at time equal 2. Let's use good notation. So v of 2 equals 2 cubed is 8 times 4 is 32. 2 squared is 4 times 6 is 24. 2 times 12 is also 24 plus 9. I get negative 48 plus this is a negative 16 plus 9 gives me, I don't get 5 like I get 7. 32 minus 48 is a negative 16 plus 9. I get negative 7. $48, $41, just making sure I didn't do anything wrong. Negative 24. Oh, I show 12 on my answer key. Did I miss something? Nope, I think my answer key is wrong. My answer key is wrong. Man, that's twice I caught my answer key as being wrong. All right, so I get negative 7 for the particle's velocity. What does that mean? particle's velocity. So v of 2 equals a negative 7. What does that mean? Particles traveling left, negative, at 7, I don't see my units, velocities per second, or velocity per second, it makes no sense, units per second, whatever we're talking about. Okay, so feet per second, inches per second, whatever units we're talking about. Okay, when is a particle at rest? When my velocity is equal to 0. So you grab your calculator, you type in this thing, solve it, and find out when that thing is equal to 0. Not trusting my answer key, I'm going to hit pause and do that one. No, I'm not. I'm going to grab my calculator and let's do it together. I think it's probably on my other screen. Sorry, this is a long video. It's an hour and 5 minutes. My prep period is going to end in 7 minutes, so we got 7 minutes to finish this thing. Yeah, I got to hit pause. It's on my other screen. I got to pull it over from my smartboard. All right, so using our calculator, we're going to go to menu. No, we're not. We're going to go. All right, so we're going to go to menu. Nope, we're going to go to home screen. Then we're going to go to menu. We're going to go to algebra. We're going to go to solve. We're going to type in 4x raised to the third power. Get out of the exponent. Minus, the bell might ring while we're talking, hopefully not. Squared minus 12x plus 9 equals 0, comma, x, hit enter, and I get that big mess. So which one do I want? I want the negative 3/2, or that mess. Did I type something in wrong? Nope. Sorry, I'm going to have to hit pause and finish this in a couple of seconds. You won't notice any difference, but if I sound weird when I come back, it's because I've had an hour and a half break in between. So, all right, I'll be back in 30 seconds. Well, for you, I won't. Never mind. Goodbye. All right, so finishing up question number, letter C. I know you don't know that it's been an hour and a half since I finished this recording, but if we look at this, I think we ended up right here where we got this answer. If you hit Control Enter, you'll get the approximate solution. So it takes this big radical mess and it gives you the approximate decimal. Negative time makes no sense. So question C, when is a particle at rest? The particle is going to be at rest when x or t equals, I lost my calculator, 0.634 and 2.66. 634, and I think it was 2.66. Let me just double check one more time. 2.366. Good thing I checked. So that's our time when the particle's at rest. And again, the negative 1.5 makes no sense going back in time 1.5 seconds. All right, so when is the acceleration? So acceleration, remember, is when velocity and acceleration have the same time. Oh, sorry, that was question D. Question D, acceleration of the particle. Take the derivative of my velocity. So derivative of velocity gives me, what would that be, 12t squared minus 12t. And ignore my answer key. Somehow my velocity derivative was not right. So let's do the derivative based upon my work I'm doing right now. So I have 12t squared minus 12t minus 12. So there's my definition, or my derivative of velocity gives me my acceleration. What is acceleration at time equals 2? plug in the 2. What is that going to be? 48 minus 24 minus 12, which is equal to 12. All right. And whatever units that would be, units per second squared, or units per second squared. Question E, when is a particle speeding up, or is a particle speeding up or slowing down at time equal to? So remember back, I don't know when it was, a long time ago, we looked at particle speeding up or slowing down happens when it speeds up when the velocity and the acceleration have the same sign. It slows down when the velocity and acceleration have different signs. So v of t we already found up here in question B. V of t is a negative 7. A of t we just found is 12. Their signs are different. The particle is heading to the left, but the acceleration is pulling it to the right. It's going to be slowing down. On your test or on the AP test at the end of the year, it'll say justify your answer, and you'll say something like because the velocity and acceleration have different signs. Okay, I hope that helps for the review. I know it's long, an hour and 10 minutes, but hopefully it helps, and I'll see you on Wednesday.